Go is a programming language developed by Google in 2007. It is a statically typed, compiled language designed for simplicity and concurrency. Go is known for its efficient and effective use of system resources, as well as its support for concurrent programming, which allows multiple processes to run simultaneously. Go is a popular choice for developing web servers, distributed systems, and command line tools, and is widely used in the industry. It has a simple and clean syntax, and its standard library provides a rich set of libraries and tools for common programming tasks. Go is a statically typed language, which means that the type of a value is determined at compile time and cannot change at runtime. The basic data types in Go are: bool represents a Boolean value, either true or false. String represents a string of Unicode characters. Int, int8, int16, int32, int64 represents signed integers with different sizes. Uint, uint8, uint16, uint32, uint64 represents unsigned integers with different sizes. Float32, float64 represents floating point numbers with single and double precision, respectively. Complex 64, complex 128 represents complex numbers with single and double precision, respectively. Let's learn more detailed explanation of the basic data types in Go, along with some examples. Bool represents a Boolean value, either true or false. This data type is often used to represent a condition that can be either true or false, such as a flag indicating whether a feature is enabled or not. For example, this example defines a variable called as feature enabled of type bool, and assigns it the value true. Then, it checks the value of is feature enabled using an if statement. If the value is true, it prints feature is enabled. If the value is false, it prints feature is disabled. The if statement checks the condition specified in parentheses and executes the following block of code if the condition is true. The else clause specifies an alternate block of code to be executed if the condition is false. In this case, the value of is feature enabled is true, so the code will print feature is enabled. If the value were false, it would print feature is disabled instead. String, you might use a string to represent text data, such as a user's name or a message. For example, this code defines a variable called username of type string, and assigns it the value, Anish. It then uses the fmt println function to print a string to the console. The string consists of the text, hello, concatenated, joined with the value of username, so it will print, hello, Anish. The fmt println function is a part of the fmt format package, which is a standard library package in Go that provides functions for formatting and printing output. The println function prints a line of output to the console, and automatically adds a new line character at the end. In this case, the code is using the plus operator to concatenate the string, hello, with the value of username, which results in the string, hello, Anish. The resulting string is then printed to the console using the fmt println function. Int, you might use one of the int types to represent a whole number within a certain range, such as a user's age or the quantity of an item in a shopping cart. The size of the integer determines the range of values it can represent. For example, this example defines two variables, user age of type int, and item quantity of type int. It assigns the value 32 to user age and the value 3 to item quantity. In the first line of code, the plus operator is used to concatenate the value of username, the string, is, and the value of user age, resulting in the string, Anish is 32 years old. In the second line of code, the plus operator is used to concatenate the string, there are, the value of item quantity, and the string, items in your cart, resulting in the string, there are 3 items in your cart. These strings are then printed to the console using the fmt function. Uint, you might use one of the uint types to represent a whole number that is always non-negative, such as the number of views on a video or the number of likes on a post. The size of the integer determines the range of values it can represent. For example, this example defines a variable called video views of type uint, and assigns it the value 100. It then uses the fmt println function to print a string to the console. The string consists of the text, this video has, concatenated with the value of video views, so it will print, this video has 100 views. The uint data type represents an unsigned integer, which is a whole number that is always non-negative. In this case, the value of video views is 100, which is a non-negative integer. Float, you might use a float 32 or float 64 to represent a number with a decimal point, such as a product price or a person's height. The float 32 type has single precision, while the float 64 type has double precision. This example defines two variables, product price of type float 32 and user height of type float 64. It assigns the value 19.99 to product price and the value 5.11 to user height. The float 32 data type represents a floating point number with single precision, while the float 64 data type represents a floating point number with double precision. In this case, the value of product price is a float 32 with the value 19.99, and the value of user height is a float 64 with the value 5.11. Complex, you might use a complex 64 or complex 128 to represent a complex number, which is a number in the form a plus b, where a and b are real numbers and I is the square root of 1. The complex 64 type has single precision, while the complex 128 type has double precision. This data type is not commonly used in real-life scenarios, but it can be useful in certain scientific and mathematical applications. For example, this example defines a variable called c of type complex 64, and assigns it the value 3 plus 4i. It then uses the fmt, println function to print the string, the complex number is, followed by the value of c to the console. In this case, the value of c is a complex number in the form a plus b, where a is 3 and b is 4. The complex 64 data type represents a complex number with single precision. The plus operator is used to add the two values 3 and 4i to create the complex number 3 plus 4i. The resulting string that is printed to the console will be, the complex number is, 3 plus 4i. Let's consider the following scenario. You are building a program that allows users to create accounts and save their personal information, such as their name, age, and phone number. In this case, you would use the following basic data types in Go. You would use a string to store the user's name, as it is a series of characters. You would use an int to store the user's age, as it is a whole number. You would use another string to store the user's phone number, as it is a series of characters that represent a phone number. For example, var name string equals Anish. This line of code defines a variable called name of type string, and assigns it the value Anish. Var age int equals 32. This line of code defines a variable called age of type int, and assigns it the value 32. Var phone number string equals phone number. This line of code defines a variable called phone number of type string, and assigns it the value. By using the appropriate data types, you can ensure that your program can store and manipulate the user's information accurately and efficiently. Thank you for following along with me. I hope you found this tutorial helpful and informative. See you in the next one.